Welcome to our lecture online. Now let's take a look at second order partial differential equations, and we're going to limit it to equations with just two variables. So here is the general equation: a times the second partial derivative of u with respect to x plus b times the second partial derivative of u with respect to x and y plus c times the second partial derivative of u with respect to y plus d times the first partial derivative of u with respect to x plus e times the first partial derivative of u with respect to y plus f times u equals some function of x and y. Wow, that's quite a general form. Now, I'm missing an e here, where a, b, c, d, e, f, and r, all these letters, represent themselves as functions of x and y. So you can see the complication here. They can all be different functions of x and y. In general, when we try to solve something like this, we'll have solutions that fall into three major categories. It can be a hyperbolic function if b squared is greater than 4ac. Now you should recognize that as something that we use in quadratic equations, so there'll be some relationship between solving a quadratic equation and solving partial differential equations. And you can see that if the condition exists where b squared is greater than 4ac, where the quantity inside the radical is positive, we have a hyperbolic solution. If b squared equals 4ac, so that the portion underneath the radical becomes 0, then we have a parabolic solution. And if b squared is less than 4ac, when the quantity inside the radical is less than 0, then we have an elliptic solution. Of course, we also have an influence of d, e, and f, and depending upon the values of a, b, and c, because after all, they are functions of x and y, and they can be such that this is not a given at any particular time. We know that there may be some deviations from those rules in some parts of the quadrants where the function will not fall into the hyperbolic, parabolic, and elliptic variety. You can see that when we try to solve something that complicated, the solution is almost impossible to get, and that's what I'm trying to say here. Notice that the solutions to this type of partial differential equation are almost impossible to figure out. And okay, we'll say, well, then what do we do with second order partial differential equations? Well, that's not really a concern so much, because typically in nature, applications of the second order partial differential equation will typically not look like that. They look much more simplified. And if you go back to that list of 5 that I gave you in a previous video, then realize, yes, second order partial differential equations tend to be much more simple than that. Typically, d, e, and f are equal to 0. So if we take a look at that, that means the two first order partial differentiations of u, they go away, and this goes away as well. And quite often, r will be 0 as well. That only leaves you with these three terms equals 0, and that would then be much, much easier to solve. Quite often, the b term also goes to 0, and we only have an a and a c term, and either this is 0 or that's a function of x and y. So those are typically the more common types of second order differential equations that we're going to find. So by all means, d, e, and f tend to be 0. And then one more simplification, what we see in most applications of the second order second order partial differential equation is that a, b, and c are not actually functions of x and y, but they're actually just constants. So if a, b, and c become constants, because that's a much more common situation of the type of partial differential equations we'll encounter, then you realize if we have these three terms that equal to 0 and a, b, and c being constants, now all of a sudden it actually becomes possible to solve these partial differential equations. And we're going to show you some examples of how to do that. So at least we wanted to introduce you to the general form of the second partial differential equation, the typical types of solutions we're going to find depending upon the values of a, b, and c. We typically realize that d, e, and f tend to be 0, and that a, b, and c tend to be constants. And r is either 0 or, yes, it could be a function of x and y, but we'll show you how to solve both of those types of second order partial differential equations. So there it is. There's our introduction. Now we're going to show you some more videos explaining how to actually find solutions to the more common types of these second order partial differential equations. Wow, that's a real mouthful, isn't it? That's how it is.